All right, we are back. This is Techmath2. We're looking at chapter 10. We're in 10.7. And so we're going to be doing something that we have done already, just not in the context of imaginary numbers or complex numbers. So we're going to be working with polar to rectangular and rectangular to polar form. All right, so if we take a look here, the symbol with this big long line like this is what you use to separate like R and the R. Remember what R was in polar form, the length of the vector, and theta was the direction of the vector. And so when you're working with imaginary numbers where you have like 8 plus 6j like this, so x is 8 and y is 6, when you convert it from rectangular, this is rectangular form, to polar form, you use this symbol. So the symbol that means angle, the angle symbol is extended under the 140 degrees, though 5 and the little angle 140 degrees are written next to each other. It doesn't mean multiply. It's just a shorthand, basically. So if we had the length and direction of a vector representing a complex number, that means with I or j in it, remember. Physicists use j, physics people. All right, so complex numbers are, let's see, 27.5 units and 228 degrees. Write it in a complex number in polar form. So what that looks like is this, 27.5, and then you do this crazy long angle, and then 228 degrees. Just like that. That's it. And so now you might say, well, why didn't we see this before when we were doing rectangular to polar, polar to rectangular? Because we weren't working with complex numbers then. Remember, this is the real number set on the x-axis, and this is the imaginary number set on the y-axis. So instead of saying 8, 6 right here, I say 8 plus 6j for rectangular. So when they want me to put number 61 in rectangular form, we go 8 plus 6j. And now let's recall how to do that. How do I go from polar to rectangular, rectangular to polar? So I know they gave us 37 degrees and 10, but just in case if you forgot, you go second, and then the angle, right? Apps is angle. And then we go down to, what do we want to go from rectangular to polar R? So if I wanted R, I'd hit enter. And now I would just put 8, 6, because it's 8 plus 6j, but I don't put in the j. I just do 8, 6, just like a point, 8, 6, and then hit enter, and that's 10. So that's where R equals 10 came from. So for polar, we have 10, and then because it's imaginary, you do this really big kind of angle sign, and we're going to write the angle inside there. Now we already know it's 37, but again, we're going to use 8, 6. We're going to go from rectangular to polar, so second angle, rectangular to polar, theta, and we'll do 8, 6 again, and then hit enter. And there is our 36.86, so we'll call it 37 degrees. And that goes in there. So just a quick reminder, polar to rectangular, rectangular to polar. So on my calculator, I would go from rectangular to polar, theta, but I'm only going to put 8, 6 in there. So I'm going to write it like a point. When I'm writing it in rectangular form, I write 8 plus 6j to show that it's imaginary and real. But when I'm actually converting it using my calculator, I just strip away the j, just do 8, 6, okay? Same with rectangular to polar R with 8, 6. And so this kicked out my 37 degrees, and this kicked out my 10. You could also go old school on it for the 10 and do this is 8, this is 6, Pythagorean's theorem, 8 squared plus 6 squared is equal to 10 squared. You know, a squared plus b squared equals c squared, that would be fine. You could also go with theta and use the arctangent of 6/8, and that'll give you the 37 degrees. If you'd rather not use rectangular to polar, polar rectangular. Okay? Also, if you recall from back in that chapter, I did show you how to also do, what we were doing, like r sine and r cosine, that kind of stuff to go polar to rectangular, rectangular to polar. So you can go back and look at those notes too. If you know your calculator isn't the same as mine with the polar rectangular stuff. All right, let's take a look at 10.8. Again, we're just going to be going the other way for 10.8. So let's do number 70. All right, and that's going to be like, so they give us 20. 40 degrees. So what does that mean? Well, that means r is equal to 20 and theta is equal to 40 degrees in polar form, basically. And they have a picture for you there too. I'm not going to bother drawing the picture. All right, so we've got r and we've got theta, but we want x and we want y. And so again, we can do the whole x is equal to, what was x equal to? Cosine. So r cosine theta, if you wanted to do it that way, instead of using, I'm not going to do it that way, and this is going to be r sine theta. So you could do that if you want to. If that's easier for you, do 20 sine 40 and hit enter, and do 20 cosine 40 and hit enter, and that'll be your x and your y. I like to go from polar to rectangular x, and then you put in 20 comma 40 and hit enter, and polar to rectangular y, 20 comma 40 and hit enter. And so I will show you that sequence in the calculator again. So we're going to go second angle, and we're going to go down to polar to rectangular x, and then hit enter, and then just do 20 comma 40 and then hit enter. Again, I've had some students go, oh, that's more screwing around than it's worth. I'll just do r cosine theta, and that's fine. It doesn't, I'm not going to mark it wrong because you did use the cosine. You're finding the same thing. I'm just doing it in a slightly different way. So 15.3. All right, and then for y, we're going to do the same thing. We're going to go second angle and then go down, and you got to go off the screen this time to the y, and then do 20 comma 40 and then hit enter, and there's 12.9, 12.8557, we'll call it 12.9. And now you have to remember, because this is complex numbers, imaginary, x is 15.3 plus 12.9j, or lowercase I. I don't really care if you use I or lowercase j, whichever one you prefer. All right? Okay, well, I just cracked open that marker. It's kind of dead already. All right, so nothing really new. I guess this part is new. You just tack a j onto that. So you found x and you found y. So you just write x plus y j. And this is considered rectangular form. Okay? For imaginaries. Let's take a look at 10.9. Now this is the easiest thing on this test for sure. Bar none, this is the easiest one or two problems on the test. Unfortunately, the division is a lot more complex, but this one is easy. I think there's one like this on the test. We'll look at the review. But if you take a look at 10-9, look at number 82. When they're both in polar form and you want to multiply a vector multiplication we're doing here, one times the other, it's super easy because you just take the numbers out front, the 3 times the 4, and you get 12. And then the angles, 20 degrees and 50 degrees, you just add them together. And you're done. That's it. So vector multiplication, when they're both in polar form, is a very, very basic process. Let's look at letter B here. We've got 7, 65 degrees times 10, 75 degrees. And so you just take the 7 times the 10, that's 70. And then you do 65 plus 75, and that's 140 degrees, and you're done. That's it. Okay? So when it's in polar form, it is super easy to multiply. And I think when they're both in polar form, it's pretty easy to divide, because you just divide the numbers, and then what you would think, subtract the angles. So that's not really that difficult. What gets difficult is when they make you convert. Like if they give you problems that are in rectangular and then you got to make them into polar and then multiply them and then change them back into rectangular. That's a bit of a process. But if it's both in polar, it's a pretty easy thing to do. All right? Awesome.